All right, hi everyone. We are looking at our next section in our unit 2 here. This is our last section of the chapter of our unit here, and we are looking at proving segment relationships, and we can also see how some of these relationships could also apply to angles that you've seen in the past. So let's go ahead and jump into this. So one of the biggest segment relationships that we looked at was the segment addition postulate, which specifically said if you have three collinear points, in this case A, B, and C, then if point B is between A and C, then if and only if AB plus BC will equal the length of A to C. So let's kind of break that down and see again about how our formula worked for these. All right, so remember, if we had our segment, again, it said A and C and B was somewhere in between. So this helped us figure out where part 1 was. And then we had part 2. Oh, sorry, that's a little big. Let me fix that. And the rule said that if we add those two up, I should be able to get the whole entire length, which was A to C. That was our whole thing. So that is basically what our segment addition property said. So when we have our AB plus BC equals AC, just remember we've got part 1 plus part 2 for the whole entire length. All right, so let's look at our next one, our reflexive property. Okay, for this one, notice from beginning of our hypothesis, from the first side to the left side, from one side to the other, no change happened. Okay, so again, that one hasn't changed. We're just seeing it now specifically with segments. The symmetric property has not changed, which said if I've got my hypothesis, compare it to the conclusion, the only thing that happened was a switch. And then we have our next property down. Again, we've seen these before, your transitive property, which said from hypothesis to conclusion. We can eliminate the repeats, so no repeats. And then our last two, more specifically, that we've been working with, we've got one which is definition of midpoint. Now, definition of midpoint could come in two different settings. If I have a midpoint, then I end up with two congruent parts. So I could have it expressed that way, with two congruent parts. The other way that I could see this property, if M is the midpoint of my segment, then the other way could have two equal lengths. Both of these are variations of definition of midpoint, so you could get either one of them. Now, when we look at definition of congruence, this is our next one. Notice both of these, for this case, whether you're dealing with segments or angles, they start off with congruent, and then they move to equal. And so that's one of the biggest things that happens with definition of congruent. So for both of these, we move from two congruent parts and that leads us into two equal measures, whether that is the length of a segment or the measure of an angle. And this definition could actually go in reverse. If I'm given two equal measures, then I could reverse it and say then my parts must be congruent. So it could go either way. So let's use these properties and justify all these different statements that we've got, matching them up to their right property. All right, so looking at the first one, we've got segment DG is congruent to segment GH. And then for the conclusion, notice all that happened was a switch, which is your symmetric. Whoops. Okay, so it's just a switch. Then if we look at our next one, Segment AB is congruent to segment RS, and segment RS is congruent to WY. And so notice the repeating information was removed, making this the transitive. All right, moving right along, we've got no change from beginning to end here, which is your reflexive. And then number 4, if Q is the midpoint of segment PR, then I get 2 equal lengths. This is a nice example of your definition of midpoint. All right, almost done, guys. All right, so number 5, if the length of BC equals the length of EF, then what's going on over here? All right, well, notice if BC is being added to the left and EF is added to the right. Well, if they are equal, you are still adding the same thing to both sides. So even though this one isn't listed in my above properties, it's still a property. We've looked at those last week. So this is technically the addition property. So all of those that we've seen before could also fall into these segment properties. All right, our last one, we start off with 2 equal parts. And then we move to, 2 equal lengths, not parts. And we move to 2 congruent parts, which is your definition of congruence. I'm going to abbreviate that and use the congruent symbol. All right, moving right along for our last 2. If angle AB is congruent to angle BC, if angle A is congruent to angle B, notice all they did was switch, which is your symmetric. And then our last one, the little line disappeared. Our last one, beginning to end, there is no change, which is reflexive again. All right, guys, I hope you enjoyed learning a little bit about how we can use some of our properties specifically with segments and with angles. So please don't hesitate to reach out to me if you have any questions at all. And I hope you guys have a great rest of your day. Bye.